We are almost there. All we have to do in this lesson is create a price list. Each price must equal the product of the price observed the previous day and the simulated daily return. Therefore, once we obtain the price in day t, we can estimate the expected stock price we will have in day t plus 1. Then, this process will be repeated 1,000 times, and we will obtain a prediction of a company's stock price 1,000 days from now. This sounds awesome, but where can we start? We already created a matrix containing daily returns, right? So the daily returns variable is available. However, which will be the first price in our list? 0? 1 million? Of course not. To make credible predictions about the future, the first stock price in our list must be the last one in our data set. It is the current market price. Let's call this variable S0, as it contains the stock price today, at the starting point times 0. With the help of the iLoc method and the index operator, we can indicate we need the last value from the table by typing -1 within the brackets. Perfect! This is the first stock price in our list. Let's proceed with filling in the list. How big should it be? As big as the daily returns array, right? This is why the price list matrix could be, at most, as big as the daily returns matrix. And, as we all hoped, NumPy has a method that can create an array with the same dimensions as an array that exists and that we have specified. This method is called zeros-like. As an argument, insert the daily returns array. We will obtain an array of 1,000 by 10 elements, just like the dimension of daily returns, and then fill it with zeros. So why did we create this object? Well, now we can replace these zeros with the expected stock prices by using a loop. Let's do this. First, we must set the first row of our price list to S0. Yes, not just the first value, but the entire row of 10 elements, because S0 will be the initial price for each of the 10 iterations we intend to generate. We will obtain the following array. Great! Finally, we can generate values for our price list. We must set up a loop that begins in day 1 and ends at day 1,000. We can simply write down the formula for the expected stock price on day t in Pythonic. It will be equal to the price in day t minus 1 times the daily return observed in day t. Let's verify if we completed the price list. Absolutely. See? And if we would like to plot it on a graph with size 10⁶, we can do that by using the matplotlib syntax. When we execute, we will obtain 10 possible paths of the expected stock price of Procter & Gamble stock, starting from the last day for which we have data from Yahoo. We called these trends iterations, since the computer will iterate through the provided formula 10 times. Here, we have the paths we simulated. Amazing, right? This was another toughie, wasn't it? We realized we got involved in more technical language and more advanced concepts, but this is the type of topics you need to master to get into the field of finance or data science. Rewind if you would like to see how the process was carried out. Next, we will learn more about derivatives and options pricing. Stay tuned, and thanks for watching.